Alright, so in this video we are going to learn how to prove trig identities, and I'm going to solve a whole list of problems, but before I do that I'm just going to give you the key points in solving trig identities. Now for most problems you have 3 steps that you want to do. The first step is just general simplification. And these are all your math rules that apply to your grade 9, 10, 11 math. So things that I'm talking about are common denominator, adding, subtracting, multiplying, and dividing fractions. And just similar simple simplification rules that you've learned in previous grades but you've never done with trig identities before. We got to apply them to trig identities now. Second thing you want to know how to do is factoring. So you want to make sure you know how to factor all types of trig equations, whether it's common factor, difference of squares, perfect square, regular trinomial, and things like that. And then the third thing you want to know how to do is you want to know all your trig identities and how to apply them. Now in grade 11 you just need to know that tan theta is sine theta over cos theta. Cot theta is just 1 over tan theta, but an easier way to write this in most questions would be cos theta over sine theta. Sec theta is 1 over cos theta, and cosec theta is 1 over sine theta. And then the last formula, but it can be manipulated in a couple of ways, is sine squared theta plus cos squared theta equals to 1. You can rewrite this as sine squared theta equals 1 minus cos squared theta. Cos squared theta is 1 minus sine squared theta. So all three the same formula, just slightly adapted. If you know and can recognize all of these things over here, you can solve every grade 11 trig identity problem. So let's start with doing a couple of questions. First one is cos theta over sine theta, and these start pretty easy but they get a bit difficult towards the end. So if you find them too easy, you can skip towards the end and look at the harder questions. Okay, so you can pick whichever side to work with. I like working with the harder side always, so I'm going to work with the right side. So I'm going to change this into 1 divided by, instead of tan theta, I'm just going to write sine theta over cos theta. I'm going to flip my fraction and get rid of the divide sign. So cos theta over sine theta. Then 1 times cos theta is just cos theta, and now my two sides are the same. Let's go to the second question. Sine theta over tan theta equals cos theta. So again, I'm going to get rid of my division over here. Since there's no fraction on the other side, I'm going to change the tan to sine theta over cos theta. I'm going to get rid of my divide sign and flip it. Sine theta times cos theta over sine theta. Now my two sine thetas cancel and I'm just left with cos theta. It's the same as the other side. One plus tan squared theta equals 1 over cos square theta. So again, I'm going to work with the more complicated side. I'm going to change my tan to sine over cos. And what I notice is I have cos square as the denominator of the other side, so I want to make a common denominator of cos square on this side. So I'm going to multiply the top and bottom here by cos square theta. So 1 times cos square theta is just cos square theta sine square theta, and instead of writing the denominator for each one, I know it's a common denominator, so I just write it together instantly to save a bit of time in this step. I know that sine square theta plus cos square theta is just 1, so my final solution is going to be 1 over cos square theta. Sec theta over tan theta equals 1 over sine theta. I know sec theta is 1 over cos theta divided by tan, I know, is sine theta over cos theta. I'm going to flip my divide. Now I can cancel off the coses and I'm just left with 1 over sine theta. Okay, as you can see, it may start a bit easy, but it does get a bit more difficult as you proceed with the harder questions. Let's go to the fifth one next. Tan theta over cos theta equals sine theta over 1 minus sine square theta. So you can work with either side, but I'm going to work with the left side. I think that's a bit more complicated. I like to get rid of tans if they're not on both sides. So if I get rid of tan here, tan is just sine theta over cos theta. And I'm dividing by cos theta. Going to get rid of my divide sign. So sine theta over cos theta multiplied by 1 over cos theta if I flip this upside down. Sine theta times 1 is sine theta. Cos theta times cos theta is cos square theta. Compared to this, just one more step. I'm going to replace my cos square theta with 1 minus sine square theta. One over cos A plus tan A equals 1 plus sine A over cos A. Okay, I'm going to work my left side a bit more complicated. I'm going to start by replacing the tan. And then I already have a common denominator, so I can just combine these. And I've got my solution. One minus cos square A equals tan A cos A sine A. I'm going to work on the right side this time. The right side is a bit more complicated. I'm going to start by turning my tan into sine over cos. Can cancel out my two coses, multiplication, division. So I'm left with sine A times sine A, which is just sine square A. And I know that sine square A can just be replaced with 1 minus cos square A, which is the other side. Sine square A over 1 minus cos A equals 1 plus cos A. Okay, if I compare the two sides here, I have no sine on this side, so I want to get rid of my sine on this side. So I'm going to convert the sine square into 1 minus cos square A over 1 minus cos A. Now here's the first question where we have to factor. If I factor this by difference of squares, gotta know your factoring methods. That's 1 plus cos A and 1 minus cos A. If you don't know how to do that, go back and learn difference of squares and then come back to this question. But you have to know your factoring really well to be able to do the harder questions. Now I can just cancel these because they're exactly the same. I'm left with the other side, which is 1 plus cos A. Tan square A over 1 plus tan square A equals sine square A. Okay, here's a bit of a harder question because we have an addition now in the denominator. I'm going to go show you how to do this. So first I'm going to start with converting my tan square into sine square A over cos square A. When I put my divide sign, because I have an addition here, I have to do this in a bracket. I'll change that tan into sine over cos as well. Now, next thing, before I can even get rid of my divide, is I gotta make a common denominator in here. So I'm gonna multiply the top and bottom here by cos square A. So I'm going to have cos square A plus sine square A over cos square A. Again, all I did was multiply the top and bottom by cos square, so I have a common denominator, and just 1 times cos square is cos square. If you don't know how to do common denominator this quickly, I would suggest learning it. It's extremely useful for grade 11 and 12 math. You can replace cos square plus sine square with a 1. Sine square A over cos square A divided by 1 over cos square A. You can flip this upside down and get rid of that sign. So sine square A over cos square A times cos square A over 1. And cancel these two, and sine square A over 1 is just sine square A, which is my other side. Cos square x equals 1 minus sine x, 1 plus sine x. Now doing this question, you can work on either side. It really doesn't matter. It's equally easy. If you worked on this side, you would have to FOIL out the brackets. If you worked on this side, you'd have to factor. I'll just do the FOIL because we haven't done that before. So if I'm foiling these two brackets, 1 times 1 is 1. 1 times sine x is plus sine x. Negative sine x times 1 is negative sine x. Negative sine times sine is negative sine square x. I'm going to cancel my like terms in the middle because they just cancel each other off in this case. So I'm left with 1 minus sine square x, which is just cos square x, which is the other side. Sine square A plus 2 cos square A minus 1 equals cos square A. Okay, again, going to work on the left side here, and if I compare the two sides, there's no sign on this side, so I'm going to get rid of this sign. I'm going to replace it by 1 minus cos square A. I'm going to combine my like terms, so 1 minus 1 is just 0 and cancels. Negative cos square A plus 2 cos square A is just cos square A, which is my other side. Sine x plus cos x square equals 1 plus 2 sine x cos x. Oops, that square is outside the bracket. Alright, so on this one, I just want to work on this side. It's much more complicated. I'm going to get rid of the square, so I'm going to write out the bracket twice. Next, I'm going to FOIL out these two brackets. So sine x times sine x, sine square x, plus sine x cos x, plus sine x cos x. And squeeze this in here. Cos times cos is cos square x. I can then combine my two terms in the middle, and then I'm going to write these two together just so that it makes a bit more sense. So sine square x plus cos square x, and then if I combine these two, plus 2 sine x cos x, then sine square x plus cos square x is just 1. So 1 plus 2 sine x cos x, and that's the other side. One over sine square x plus 1 over cos square x equals 1 over sine square x minus sine 4x. Okay, so you may think you want to work with the right side over here because it's more complicated, but technically the left side is the one you should work because you always need to make a common denominator, especially if it exists on the other side. So I'm going to work with the left side and make a common denominator. I'm going to multiply cos square on the top and bottom and sine square on the top and bottom here. If I multiply cos square with 1, I get cos square x. Sine square x with 1 will be sine square x, and my common denominator is just sine square x cos square x. You can replace the top with a 1. So 1 over sine square x cos square x. If I compare this to the other side, the 1's are the same, and there's sine, but there's no cos, so I need to get rid of the cos. I know I can replace cos with 1 minus sine square x. Then I finally just have to multiply this into the bracket to get the other side. Cos x plus sine x tan x equals 1 over cos x. I'm going to get rid of my tan first, so cos x plus sine x times sine x over cos x. I will multiply this or simplify this over here, pretty simple. So sine x times sine x is sine square x. Now I want to make a common denominator, so I'm going to multiply the top and bottom by cos x. So I have cos square x plus sine square x over cos x. Cos square x plus sine square x is just 1. So I'm left with 1 over cos x. Sine square x over cos square x times 1 over tan x equals tan x. Now you may be tempted to get rid of the tan x on this side, but if you look at the other side, there's only tan on the other side. So I instead want to convert this sine over cos into tan. And that's going to be tan square x times 1 over tan x. So if I simplify this, tan square x times 1 is tan square x. So it's just tan square x over tan x. If I cancel, I'm just going to be left with tan x. Cos square a minus sine square a over cos square a plus sine a cos a equals 1 minus tan a. And I'm going to work on this side here. Now, if you can't recognize this at first glance, you can factor the top and the bottom. The top can be factored by difference of squares. The bottom can be factored by common factor. So let's factor. The top will be cos a minus sine a cos a plus sine a. And the bottom, I can common factor out a cos a. I'm left with cos a plus sine a. Cancel out these two. So I'm just left with cos a minus sine a over cos a. Now in order to get the other side here, I need to split my denominator. You can only do this when you have one term on the bottom, nothing being added or subtracted. So I'll split it into cos a over cos a minus sine a over cos a, which is just 1 minus tan a, which is the other side. Tan square x minus sine square x equals sine square x tan square x. Okay, a bit hard to tell which side is more complicated, but always work with additions and subtractions. They're the more complicated side rather than multiplication. I'm going to convert my tan square into sine square x over cos square x because there's literally nothing else that I can really do over here. I'm going to make a common denominator, so I'm going to multiply cos square x on the top and the bottom. Now I'm going to common factor on the top. I notice there's a common factor of sine square x. I'm going to be left with 1 minus cos square x. I can replace 1 minus cos square x with sine square x. You don't really need the bracket, but I'll put it so it's a bit more clearer. Then if I compare to the other side, sine square x's are the same, and sine square x over cos square x is just tan square x. So my final solution, sine square x, tan square x. Tan square x minus cos square x equals 1 over cos square x minus 1 minus cos square x. Okay, so if I compare these two, the hardest side is the right side because the denominator is over here. One more thing I want you to notice is negative cos square x's are exactly the same. So I'm not going to touch this. I'm only going to work with this part here and try to make it equal to tan square x. I'm going to start by making a common denominator with just these two terms. So I'm going to multiply cos square x on the top and the bottom. I'm going to leave this the same. Don't need to touch that at all. I'll just combine these. One minus cos square x is just sine square x. And sine square over cos square is just tan square. I'll complete it over here. So tan square x minus cos square x, which is the same as the other. side. Okay, so again, I'm going to work with my left side here. I'm going to make a common denominator. So I'm going to multiply the top and bottom by 1 minus cos A, 1 minus cos A, and here 1 plus cos A. So here I have 1 minus cos A. Now here I have 1 plus cos A. And then I have a common denominator of 1 plus cos A, 1 minus cos A. Compare my other side, the bottom is sine and then the top is 2. So in the top, 1 plus 1 is 2. Negative cos A and cos A, they just cancel off. And for the bottom, I need to manipulate the bottom as well to get it as sine. So I'm going to FOIL out my two brackets. 1 times 1 is 1. And minus cos A plus cos A minus cos square A. And cancel those like terms. So I'm left with 2 over 1 minus cos square A, which is 2 over sine square A. One plus 2 sine B cos B over cos B plus sine B equals sine B plus cos B. Okay, so here is a really hard one. It's not difficult in the sense that it's a really long problem or super difficult problem. It's difficult in the sense that if you don't know what to do, you'll never be able to solve it. Now what you need to be able to recognize is that 1 can be changed into sine square B plus cos square B. I'm going to touch the bottom, it's going to stay the same. So now what do I do with this on the top? I'm going to rewrite it in a slightly different way. I'm going to move the cos square B to the end. And what you notice here is this is now a perfect square. You can factor it. That's the whole reason I did that. If you factor this, it's just sine B plus cos B squared and now I can just cancel. I'm left with sine B plus cos B. So definitely a pretty difficult one unless you can recognize in a question when perfect square patterns show up. And I can recognize it anytime you see 1 plus 2 sine B cos B, you know it's most probably going to be some kind of perfect square. One minus cos square x, 1 minus tan square x equals sine square x minus 2 sine 4x. Alright, so now they're going to start to get really difficult. 1 minus sine square x. Okay, so again, both sides are pretty complicated, but me personally, I would work on the left side over here. Something I noticed on the right side is there's signs in all the terms on the top. So I'm going to convert this 1 minus cos square into sine square x. And at the same time, I'm going to convert this tan square into sine square over cos square. And the reason I did that is because if I see the bottom is 1 minus sine square here, which cos square x will eventually turn into. I'm going to make a common denominator over here now. So sine square x. I'm going to multiply cos square on the top and bottom. So cos square x minus sine square x over cos square x. Pretty complicated. So the next thing I want to do is I want to convert this. There's no cos square on the other side, so I want to convert both these cos squares into 1 minus sine squares. So 1 minus sine square x minus sine square x over 1 minus sine square x. I'm going to combine these two like terms, so it's going to become 1 minus 2 sine square x. If you subtract those, bottom is 1 minus sine square x. And then last step, multiply this into the bracket, you get sine square x minus 2 sine 4x over 1 minus sine square x, which is basically the other side. Tan x sine x over tan x plus sine x equals tan x minus sine x over tan x sine x. Okay, honestly, it doesn't matter what side you work on, they're equally complicated, so I'll just work on the left side. Let's see what happens. I'm going to convert this tan into sine over cos. Sine x. And when you divide, make sure you put your bracket, because there's an addition in the bottom. Tan is sine x over cos x. Multiply those, so that's just sine square x over cos x multiplied by, divided by. I'm going to make a common denominator here, so multiply cos on the top and bottom, so sine x plus sine x cos x divided by cos x. I'm going to flip this upside down, so sine square x over cos x multiplied by cos x over sine x plus sine x cos x. I'm going to cancel out my two cos x's over here. So I have sine square x over sine x plus sine x cos x. Now this doesn't match anything at all on the other side because it's too complicated to actually get this to the other side. So now what you want to do is you want to take this side and you want to simplify it as well, and you want to get to the same thing as over here. So I'm going to start with this. I'm going to change tan x into sine x over cos x minus sine x divided by tan is just sine x over cos x, and then you have sine x. I'm gonna make a common denominator. Again, you need a bracket here for this, just because if there's a fraction and addition subtraction, you have to always bracket things being added or subtracted. I'm gonna make a common denominator here. That's sine x minus sine x cos x over cos x divided by sine square x over cos x. I'm going to flip this. So sine x minus sine x cos x over cos x multiplied by cos x over sine square x. Cancel out the coses. I'm left with sine x minus sine x cos x over sine square x. Alright, so now let's compare these two, and we need to make these two equal to each other, which is still a bit difficult. It's a trig problem of its own, but I'm going to help you how to do that as well. What you want to start by doing is you want to factor the top and bottom of these sides, and you want to convert the sine square x's into 1 minus cos square x's. But I'll factor first, and then I'll explain why I'm going to convert that. So if I factor out sine x here, I'm left with 1 plus cos x. And if I factor out sine x here, I'm left with 1 minus cos x. Okay, now I can simplify this. I can cancel out the signs, or I can actually convert that. There's two possible things that I can do, but rather than cancel out the signs, because I have a sign on the bottom and sign on the top here, I don't want to cancel out the signs. Instead, I want to convert sine square into 1 minus cos square x. I'm going to do the same over here. Now I'm going to factor these so I can do a cancellation. So if I factor 1 minus cos square x is 1 plus cos x, 1 minus cos x, and same thing on this side. I know, extremely long problem. There might be quicker ways to do it, but we're almost done. So over here I have 1 minus cos x over sine x. Over here I have sine x over 1 plus cos x. So now here's a new trick we're going to learn in this problem. If you have a thing like this where it's the opposite things on the top and bottom, you just want to take one and kind of multiply it on the top and bottom of the other side. Because if I multiply 1 plus cos x on the top and bottom here, my denominators are going to get a lot closer. And yeah, there's definitely quicker ways to do this, because it's kind of similar to this over here. Because if I compare this step to this step, actually I don't need to do all these extra steps. I can actually cancel all that out. That's the same as this. So I did do this one a bit extra long. You can just cancel out the sine and the sine square, and you get the exact same thing as the other side. So that is one of the problems with trig identities. Sometimes you may do extra steps when trying to figure it out. There's no exact right solution, but as you can tell, sometimes you have to work on both sides, and the questions are a bit complicated. minus 2 cos square x equals sine 4x minus cos 4x. I'm going to work on this side over here, the right side. It's a bit more complicated. You can tell that this is difference of squares. So I'm going to start by converting this into sine square x plus cos square x and sine square x minus cos square x. That's my difference of squares. Sine square plus cos square is just 1. Then I have to just make this, I multiply the 1. I can replace sine square. There's no sine square on the other side, so I can replace sine square with 1 minus cos square x. Then I just combine like terms, so I get 1 minus 2 cos square x. Cos x tan cube x equals sine x tan square x. I'm going to work on the left side here because I have a cube. If I notice, I have tan cube and tan square on this side, so I'm just going to break this tan cube into tan x and then tan square x. Now the tan squares are exactly the same, so I don't have to change those. I can change my tan into sine x over cos x. The two coses just cancel, so you're just left with sine x tan square x. Almost done here. Only 6 more questions to go. Sine square x plus cos 4x equals cos square x plus sine 4x. Okay, again, looks like a complicated one like the other one. Looks like a pretty long one. So there's no difference of squares over here. There's not really much you can kind of change. So what I'm going to do is I'm going to break down this cos 4x into cos square x times cos square x. Okay, and the only reason I'm doing this is because I don't know what else to do. Not really much else I can do. I could convert that into something else, but there's no 1 minus, there's no negative cos square x on this side, so I don't want to do that. Now I'm going to convert this into 1 minus sine square x. Okay, so now I'm going to multiply this into the bracket. Alright, so what you notice is the cos square x's are exactly the same now. I'm just going to write this in the front because I'm not going to change that, and I'm going to work with the rest. I'll put this next, plus sine square x minus cos square x sine square x. So I just need to turn this all into sine 4x. Now to do that, I can common factor out sine square x over here, and I'm left with 1 minus cos square x. I know 1 minus cos square x can just be converted into sine square x, and then if I multiply these two, that's my final solution. Tan square b plus cos square b plus sine square b equals 1 over cos square b. Okay, this one should be pretty easy at this point. I can convert my tan into sine over cos. And I know cos square plus sine square is just 1. I can make my common denominator next. And multiply the top and bottom by cos square. And then sine square plus cos square is just 1. Sine square x 1 plus 1 over tan square x equals 1. Okay, so on this question, what I want to do is I want to first convert my tan square. So I'll show you how I do that. If tan square is sine over cos, 1 over tan square is just cos over sine. It's the opposite because it's a reciprocal. I want to make a common denominator on the inside. Sine squared plus cos square is just 1. And then sine squares cancel off and your final solution is 1, which is just the other side. One minus cos b over sine b equals sine b over 1 plus cos b. So this was the kind of thing that I was mentioning in that really difficult question. We came across this in the middle of the question. But you want to do this unorthodox step of 1 plus cos b multiplying the denominator of the other side on the top and the bottom. This is very rare, but it does happen when things like kind of crisscross like that. There's also a couple of other ways you can multiply sine on the top and bottom as well, but we'll just do it this way. So I have 1 minus cos b 1 plus cos b over sine b 1 plus cos b. Next you want to FOIL out the brackets on the top, so I have 1 plus cos b minus cos b minus cos square b over sine b times 1 plus cos b. Combine my like terms in the top, so I have 1 minus cos square b over sine b 1 plus cos b. Can replace 1 minus cos b with 1 minus cos square b with sine square b. And finally the sine and the square will cancel and you're left with the other side. So again, completely different method to what we've done before, very unorthodox, but these questions do appear and that's an easy way to solve them. Okay, almost done, just 2 more questions to go. Sine x over 1 plus cos x equals 1 over sine x minus 1 over tan x. I'm going to work with this side here because I want to make a common denominator that's going to make things a lot easier. So I'll start by just turning the 1 over tan. So 1 over sine x, 1 over tan is just cos x over sine x. Looks like I already have a common denominator, so I'm just going to combine them. And now this is the exact same as what we did in the previous question. I'm just going to multiply the top and bottom over here by 1 plus cos x. just bracket it in the same step, but literally exact same as when we reach this point here is exact same as the previous question. I'm going to FOIL out those two brackets. 1 plus cos x minus cos x minus cos square x sine x 1 plus cos x. Combine like terms, those cancel, so 1 minus cos square x over sine x 1 plus cos x, and then factor the top by difference of squares. Finally, just, oh no, I went backwards, sorry, not factor, turn it into sine square x, and finally just cancel the sine and the square, and you're left with sine x over 1 plus cos x. Alright, last question. Sine square alpha minus cos square alpha minus tan square alpha equals 2 sine square alpha minus 2 sine 4 alpha minus 1 over 1 minus sine square alpha. Feels like we did this question before. We did do it. Oh no, we didn't. Almost did it. We did a very similar one, but the steps are pretty much exactly the same. Right side looks more complicated, but you want to work on the left side because the left has a tan. It's going to create a denominator. We can get the right side. So very similar to the last question, but a bit more difficult, slightly more difficult than the other one that's very similar to this. So there's no cos on the other side, so I want to convert this cos, but before I do that, I'm gonna just get rid of the tan. It's better to do things one step at a time. Take everything one step at a time, and things will make a bit more sense. Next, I want to make a common denominator, but I also want to get rid of this cos. So I'm wondering which one would be smarter to do. I think it's going to be smarter to get rid of the cos first. It'll be extremely long if you make a common denominator first. I can kind of just tell that from experience. So I'm going to get rid of cos and turn it into 1 minus sine square alpha. Make sure you include your bracket here because there's a negative outside, and that's the really hard part in this question. I'm going to get rid of my bracket. And now I'm going to combine like terms. So sine square plus sine square is 2 sine square alpha minus 1 minus sine square alpha over cos square alpha. Now I'll make my common denominator. It's going to make things a lot easier. I'm going to multiply the top and bottom here by cos square alpha. Same with this. Now I have my common denominator of cos square alpha. If you compare the two sides here, at this point, it's still very different, but you notice there's no cos square at all on the top and bottom, and we have a bunch of cos squares over here. So I'm going to get rid of all my cos squares. Okay, again, don't forget your bracket here because there's a negative there. And next, I'm just going to get rid of my brackets. I'm going to multiply my terms into the brackets. So this is going to be 2 sine square alpha minus 2 sine 4 alpha minus 1 plus sine square alpha minus sine square alpha. Negative times negative is positive. Bottom is still the same, it matches the other side, and what you notice now is that these two just cancel to the exact same opposite signs, and we're pretty much left with the other side, which is our final solution. So 2 sine square alpha minus 2 sine 4 alpha minus 1 over 1 minus sine square alpha. And that's it. Our final question was the most difficult one. I would suggest practicing a lot of trig identity questions. They are really important. It's a very difficult chapter, but it preps you really well for grade 12 advanced functions to do this kind of math. So I'd strongly suggest trying to get really good at this. You're going to see the same thing but more difficult in grade 12 as well. Yep, so if you enjoyed this video, please like and subscribe.